All right, this is the last section in Unit 447, which is called L'Hopital's rule. This is going to be going back to the limits that we did a long time ago, and we did these algebraically by factoring, reducing, and finding them. L'Hopital is a shortcut to doing this, and on any time you have a limit, the first thing you're going to do is plug this number in for both of these. So when you get this, you plug in 2 minus 2 and get 0. And you plug in 2 squared, which is 4 minus 4, you get 0. Or down here, if you plug infinity in, this right here is infinity squared times a negative, so that goes to negative infinity. And then down here, you take the biggest one, that's infinity squared times a positive, is positive infinity. Now, if you ever write these in this form, you will lose a point because you're not allowed to write them in this form. But over here are the most common. These are the most common called indeterminate forms you can get. And that's why you're not allowed to write them in these forms, because they're indeterminate. These things don't really exist. Also, 0 times infinity doesn't exist, all these things. Infinity minus infinity, 1 to the infinity, all this stuff does not exist. So you're not allowed to write anything like this, but this is what they look like if you were to do direct substitution in there. So if you get anything like this, that means that we're going to be able to use L'Hopital's rule. So if you study L'Hopital, again, you get any of these forms or any other ones, there's going to be other indeterminate forms that you'll study in BC if you go that far. And then we're going to look at these. Now it says, notice the two limits we've introduced at the top of the page are rather easy to solve by factoring, which we did way back when. If we want to find a limit as 0 approaches this thing, this is not going to be able to be solved by factoring. If you do cosine of 0, you get 1. So 1 minus 1 would be 0, and 0 minus 0 is 0 over 0. But if you look at this, as we approach from the left, and we approach 0 from the right, the y value of this thing is 0. Okay, now the reason that works is we're doing the limit as x approaches 0. And the top part is we can write that cosine x minus 1, and we factor an x out of here. You can put an x here, and then that'll be times 1 over x minus 1 if you factor the GCF out of the bottom. If you remember, this is a Bible verse that this thing right here is 0, but when you put 0 in here, you get negative 1, and 0 times negative 1 is 0. Likewise, this limit as x goes to infinity means we're going this way. And it's hard to see, but this thing keeps approaching this value right here, and this whole value would go to 1. Well, these are not easy to find algebraically. So L'Hopital makes them easier. So to use L'Hopital, it says we have one of the two following cases. We either get 0, and this is the way you have to write it. You cannot write 0 over 0. You have to show the top will be 0 and the bottom independently will be 0, or the top goes to infinity, one of the infinities, and the bottom goes to one of the infinities. You're not allowed to write those like I did at the very beginning. So if I do this one right here, we need to say that the limit as x approaches 2 for 3x squared, this is doing the top one, minus 7x plus 2, and you plug 2 in here, and you're going to get 4 times 3, that's 12. 12 and 2 is 14. Negative 7 times 2 is 14. That goes to 0. And you must also show a limit as x approaches 0 for the bottom part of x minus 2, and I put 0, and it should have been a 2 again, my bad. This is also 0. You must show the top and the bottom independently. So then you say by L'Hopital. So by L'Hopital, and you can abbreviate this, by L'Hopital, this says that the limit of an original function also equals the limit as the function goes to the same number of the derivative of the top over the derivative of the bottom. This is not quotient rule. So what we can say is this will equal, by L'Hopital, I guess I should say it down here, this will equal the limit as x approaches 2, and then I can do the derivative of this. So 2 times 3 gives me 6x on top. The derivative of negative 7x is negative 7, and on the bottom, the derivative of x is 1. Now I plug 2 in there, and I get, I'm going to come down here, and I get 6 times 2 minus 7 is 12 minus 7, or 5. So this limit is 5. Now you could also factor this and get the same thing, but this is a little quicker. So again, you're going to show that if you plug in -3 there, you would show the top goes to 0. And you plug -3 in there squared is 9. 9 minus 5 is 4. The square root of 4 is 2. 2 minus 2, that goes to 0. You would show it like this. But then we would say by L'Hopital, and I'm going to do the derivative of the top. So when I do the derivative of the top, the limit as x approaches -3, you keep this the same. The derivative of the top is 1, and down here in the bottom, and we got to think of this as x squared minus 5 to the 1/2 power minus 2. We do chain rule on this. So we take a half to the front, we subtract 1 from the power, and then we go in and do the derivative of the inside part, which would be 2x. And I hope we see this 2 and this 2 reduces. So we're going to have x on the bottom, and we're going to move that up to the top. So this would be the square root of x squared minus 5, because a negative can be moved. And down here on the bottom, we still have that x right there. And we have not plugged anything in, so we still have the limit as x approaches -3. So we plug that -3 in there, we get the square root of 4 again, because that's 9 minus 5 all over -3. So this would be -2/3. Okay, we come on down here and do the same thing. If I plug -2 in here, that's -8. That's plus 4. That's plus 16. And that's minus 12. And you're going to show that that equals 0 all by itself. And then you come down here and you get -8 again. Here you get plus 32. Here you get -40 and plus 16. And you would show that that's -48, positive 48, that this also goes to 0. Okay, now you got to do those separate just like this, but to save some room here to work the problem out, I'm not doing that. So I say by L'Hopital, and you can abbreviate again, by L'Hopital, and I'm going to do the limit as x approaches -2. And I do the derivative here. So this is 3x squared plus 2x minus 8. And then I got 3x squared plus 16x plus 20. So now I'm going to plug -2 in here again. So when I do that, I'm going to get 12 minus 4 minus 8. Uh-oh, that's 0. And then this one down here, I get 12 minus 32 plus 20. That also is 0. Now I have to show these individually. I need to do it like this again, but they're both 0 again. So then I would say, by L'Hopital again, I can do the same rule because they both go to one of the indeterminates, 0 over 0. So then I do the derivative of that again. So you can keep doing this until you get to an answer. So this would be 6x plus 2 on top, and on the bottom would be 6x plus 16. And then we plug in the numbers, and we're going to get 6 times -2 plus 2. And down here, we're going to get 6 times -2 plus 16. So that's -12 plus 2 is -10. And -12 plus 16 is 4. And there's your answer. If you want to reduce it to -5 over 2, you can, but that's our answer right there. And I'm going to do one more of these and get this out of the way. So I got room to work this one out. And again, I'm going to do this one because I got lots of room below. It says the limit as x approaches 1 of 5x to the 4th minus 4x squared minus 1. And I'm going to say that's going to equal 5 minus 4 minus 1, which is 0. And then you do the other one individually. This is what you have to do each time. If you don't do this, you lose points on the AP test. You're not allowed to write 0 over 0. So this would be 10 minus 1 minus 9, 0. And then I say by L'Hopital. As soon as I get one of those indeterminate forms, this would be 0 over 0. I can do L'Hopital. So by L'Hopital, the limit at this thing also equals the limit as x approaches 1. And then you do the derivative of the top. So that'd be 20x cubed minus 8x. And then the derivative at the bottom will be negative 1 minus 18x. So if I plug 1 in here, that's going to be 20 minus 8, which would be 12. So this is not going to be 0 over 0. So this is 20 times 1 cubed minus 8 times 1 all over negative 1 minus 18 times 1. So let's see, that's going to be 20 minus 8 is 12 over negative 19, and that would be our solution. So that's how L'Hopital gives you a shortcut right there, which is pretty awesome stuff, really. Okay, now I want to make sure that we see this thing on the next page. It was at the bottom or at the top. You are never allowed to show 0 over zeros or infinities over infinities. So I want to make sure you realize that. I've said it several times and showed you on these, especially this one and the first one, that you can't do that. Okay, so coming down here, find each of the following limits. So again, you plug 0 in there, and you're going to have to show this top thing all by itself goes to 0, and this bottom thing goes to 0, just like we did the other ones. And then I can say by L'Hopital, and I'm going to do the derivative of each. So when I do the derivative of cosine, redo my fraction bar as x goes to 0. The derivative of cosine is negative sine x, and you do the derivative down here and you get 2x minus 1. So now we plug in. So the negative sine of 0 all over 2 times 0 minus 1 is going to be 0 over negative 1 equals 0. So there's our solution. That's the one we did earlier with the graph. Coming down here to do this one. Okay, we plug in 1 here. You're supposed to know that's 0 minus 1 plus 1. So that shows the top one's going to go to 0. And again, you have to do these individually. And this is e to the 1, which is e, and that's e minus e. E minus e is 0. So we're going to say that this by L'Hopital, and we're going to do the derivative. So the derivative of natural log of x is 1 over x minus 1. And then we come down here and we're going to do the derivative of e to the x is e to the x. Now that's e to the first. So this is a number. This is a coefficient. So this would just be minus e. And then we're going to plug 1 in up here. Well, we got a problem again because 1 over 1 is 1, and that goes to 0. And e to the first minus e, that's 0 again. So I have to do the derivative again. So I want to think of this thing right here as being x to the negative 1 when I do the derivative of the top again. So I say by L'Hopital again, and it's going to be the limit as x approaches 1. And e, the derivative of x to the negative 1 is negative 1 x to the negative 2, which is over x squared minus, that's nothing because the derivative of a number is nothing. And then the derivative of e to the x is still e to the x, and this is a number, so this is nothing again. So now I'm going to plug 1 in again, and I'm going to get negative 1 over 1 all over e to the first. So this will end up being negative 1 over e, which is the solution on that one. Coming down here now, this is infinities. So to me, infinities are horizontal asymptotes. So I would not use L'Hopital on this. I would just use my shortcut. You see the biggest exponents are x squareds. So this means that the horizontal asymptote is y equals negative 5/3. That is going to be your horizontal asymptote using the shortcut. So I would not use L'Hopital on that. Now, if you did use L'Hopital, you will still end up getting the same thing. Again, on this one, now this one I don't have a choice. So when I plug in infinity up here, this is infinity, doesn't matter what these are, this is bigger than the rest of them. So your top, and you're supposed to do again, this individually goes to infinity. And plugging infinity down here into this one is bigger than this one, but they're still both positive numbers. So this one goes to infinity. So now we do by L'Hopital. So when we do the derivative of the top, we get the limit as x goes to infinity. And then up here we get 8x minus 5 And then down here, we get e to the 5x. We're doing the derivative, so we have to do the derivative of 5x again, which is 5. And then this would be plus 1 over x. Okay, so when you do that, you got a couple options on this one. You could, well, let's just plug in and see what we get. So if I plug infinity in up here, you're going to see that this is going to go to infinity. So this one goes to infinity. And down here on the bottom, this one is going to be infinity over 0, because if you take one cookie and divide it by the world, this goes to 0. So this is infinity plus 0 is still infinity. So this is still infinity over infinity. Okay, so I do by L'Hopital again. So on the top, we're going to have the limit as x approaches infinity, which is going to be 8 on the top, and down here on the bottom, this is 5e to the 5x times, again, you got to do the derivative of this again. So that's 5 in front. 5 times 5 makes that 25. And then again, this is x to the negative 1, so this is going to be negative 1 over x squared like it was before. And then we're going to plug infinities in here again. So on the top, you got 8 no matter what. On the bottom, this whole thing goes to infinity, and that's 1, so this is 8 over infinity. So now you got 8 cookies divided by the whole world. This goes to 0. So this stuff's a little tricky, but you got to just keep going until you find it. And I think this is the last problem, maybe. I think. No, we got more. All right. So this one says use the graph to find this. So you want the limit as x approaches 3. Yeah, that's a 3. So here's 3 right here. So from the left and the right, this goes to 0, and you should show this individually again, and then 3 squared minus 9 is 0. So we say by L'Hopital, this will equal the limit as x approaches 3 of f prime of x over 2x. So now we're approaching 3 of f prime. Well, you got to know that f prime, now this graph is f, this is the f graph, because it says up here. So the f right here is we need the slope of this graph. We need the slope of this right here, which is down 2 over 1 or down 4 over 2. But the slope of that is negative 2 on the top. And then you plug 3 in down here and you get 6. So this equals negative 2 over 6. Just leave it that way, or negative a third. And we got this last one right here. So we want to plug 2 in here. So f of 2. So f of 2 makes this a 4. So you should show the top part's going to 0. You plug g of 2 in down here. So you plug 2 in. G of 2 is 0. And 0 times anything is 0. So this one goes to 0. So we say by L'Hopital. And we do the derivative. So when we do the derivative, we get f prime. Oops, I forgot the limit. We keep the limit as x goes to 2. And we get f prime of x. And the derivative of 4 is nothing. And then this is product rule. So we got to do first times derivative of the second plus the second times derivative of the first. And now we're going to plug 2's in here. So f prime of 2. Well, plug 2 in for f prime, you get out negative 2. So you get negative 2 on top. Coming down here, you got g of 2. So g of 2 is 0. And it doesn't really matter what this part is. It's 4, but 0 times 4, so that's still 0. And then you got plus over here. 2 squared is 4. And then g prime of 2. G prime of 2 is 3. So this whole thing would equal negative 2 over 12, which you could reduce to negative 1/6. All right, this is the last problem, and this is off the 2018 AP exam. This is an open-ended question. So it's part D of it. So it says, let f be the function defined by this. Let g be the differential function such that g pi over 2 equals 0. The graph of g prime, the derivative of g is below. So this is the g prime graph right here. Find the value as limit approaches pi over 2 of f of x, g of x. So again, I'm going to do this one normal, like you should do, and you would do the top part. And it tells you that see, as x approaches pi over 2, so we want to plug in pi over 2 for these things. So this is e to the pi over 2 times cosine of pi over 2. And cosine of pi over 2 is 0, so that's 0. And the limit of g of x, oops, sorry, the limit as x approaches pi over 2 of g of x, so you plug pi of 2 in here, well, it tells you that is 0. So then we say by L'Hopital. So now we're going to do the derivative of this thing, which is product rule again. And we're going to get the x as x approaches pi over 2 again. And then we do the product rule up here. So it's first derivative of the second plus the second derivative of the first all over the derivative of the bottom part, which is g prime of x. Okay, so now we're going to plug in pi over 2 to all these. So you're going to have e to the pi over 2 and minus the sign times negative sign of pi over 2. And then over here we got plus cosine of pi over 2, e to the pi over 2. And down here on the bottom we got g prime of pi over 2. So pi over 2, g prime means this value that's over here, because this is g prime. So that's a 2. So if you want, we could go ahead and solve this. Sine of pi over 2 is 90 degrees, so this is 1. So this is actually a negative e to the pi over 2. And over here, this is 0, so that's plus 0. 0 times that is still 0, so that is over 2. And there's your answer. So that's the notes for 4-7, and we're going to be quizzing in about a week. So I'll see you guys next time.